So the first two that we're going to do are 60 and 126. And so what I want you to do there is first do prime factorization for each of those, either short division or factor trees. And when you get down to the prime factorizations, I want you to find all of the numbers in the prime factorizations and line them up next to each of these. So you'd say, well, 60 is 2 times 2 times 3 times 5. And 126, factored right here, is 2 times 3 times 3 times 7. I hope in your random collection of tiles you have at least that. Yes? Okay. So it's important that you do these on two lines, one above the other, because of what we're going to do next. Okay? Rather than writing out every possible factor, which takes a while, right? You can actually look at this prime factorization and get it right away. What you do is you line these up so that anytime there's a repeat, they're on top of each other. So like there's a repeated 2, there's a repeated 3, the 5 doesn't have any repeats, the 7 doesn't have any repeats, right? So anytime you do have a set of repeats, they're there, okay? So then the greatest common factor is actually looking at these repeats. Anytime you have something that's in common to both, it's in the GCF. So 2 would have to be in the GCF and 3 would have to be in the GCF because it's in both this line and this line. Okay? So our GCF for this would be 6. So we could write GCF of 60 and 126 is 6. Okay? Do another one. So let's do, well, let me say first, it sounds like you guys have a question about it, so. You can't stack them like that. So you have to have both in both in order to take them both. Okay? I'll show you one of those next. Let's look at here's one. Let's look at 100 and 330. $100 and $330. So we start with that, okay? But we have to line them up so that if there's any repeats, they fall in a line, okay? So we've got these 2's that are right on top of each other, right? But there's not another 2, so there's nothing we can put under that, right? Any 3's that fall on top of each other? No, so we move this over. There is a 5 that's a pair, and then there's another 5 which we don't have a repeat for, so those are our empty spots. Does that make sense? And so then the GCF for this would have to have the 2, because that's in both, and it would have to have the 5, because that's in both. And so our GCF would be 2 times 5, which is 10. And we know that there's not anything bigger. You might have been able to look at that and go, yeah, 10's a factor, but you have to be sure that there's nothing higher than 10. Okay, so this is a guarantee of that. That is a little easier than writing out all the factors of 10 or 100 and all the factors of 330, isn't it? A little bit? Okay. Let's do this with something really big, just to prove it. So let's look at 735 and 650. You may have to use your divisibility rules here a little bit to think about what goes in. $13 might be a tough one if you don't have that in your pile. Okay, so now we'll line them up. Everyone get the factors all right? So line them up. There's no line up for 2, so that's not there. And there's no line up for 3, so that's not there. The first one that lines up is 5. Not another line up for 5. And not any lineups for 7. So the only place this overlaps is 5. So the greatest common factor is 5. And we're done. Okay? Kind of slick? This also works for the greatest common multiple, as we'll see in a second, which is even more of a pain than greatest common factors are. Okay? So we're going to go back to the other video. Just stay where you are because we're going to use this again. So don't pack it all up. I just need to go over there for a second. So we'll stop this.